Hi and welcome to section 7.2. This is video 1 of 2 videos for this section. In this section we're going to have an important topic, one that will be on your exams, very likely on the final. This is addition and subtraction formulas. You're absolutely going to want this on your cheat sheet, and you will absolutely want to have it memorized for the final exam. I'll show you some tricks to sort of simplify how to memorize these, because you'll see a couple patterns developing here, but nonetheless this will be something you'll have to know. So first, for sine, we have the following. Sine of s plus t is equal to sine of s cosine of t plus sine of t cosine, sine of t cosine of s. So sine of s plus t is sine of s cosine of t, sine of t cosine of s. And sine of s minus t is sine of s cosine of t minus sine of t cosine of s. So this is our addition subtraction formula for sine. So what are our tricks to remember this? Move this back a little bit. So our tricks are what? Well, when it's addition of sine, it's the same. So sine of s plus t, I'm going to have a plus sign over here. Sine of s minus t, I have a negative sign. And then what? It's what? Sine cosine, sine cosine. And then it's just st, and because I use sine of s over here, I need to use the other one, t, in this case. So it's sine cosine, plus if it's plus, minus if it's minus, and then st, and then ts. So that's how you can try to remember the sine addition subtraction formulas. For cosine, we have cosine of s plus t is equal to cosine of s cosine of t minus sine of s sine of t. And cosine of s minus t is cosine of s cosine of t plus sine of s sine of t. So now you can see how this differs a little bit from sine. With sine, if it was an addition, I stayed with addition. Down here with cosine, it's the opposite. So if you want to think like cosine has an O in it, O for opposite. So if I'm adding s plus t, I got to subtract them over here in the formula. And then it's always what? Cosine, cosine, sine, sine. Cosine, cosine, sine, sine. And then no matter which one you have, s or t first, you're multiplying together so you'll get the same value. So that's the way you can remember cosine. The biggest thing is the signs are opposite, and then it's just always cosines and just sines, whereas sine, it's the opposites. It's both on both sides. All right, let me erase this, give you the tangents. So addition subtraction formula for tangent. We have tangent of s plus t is equal to tangent s plus tangent t all over 1 minus tangent s times tangent t, and then tangent of s minus t is tangent s minus tangent t all over 1 plus tangent s times tangent t. So this one's a little little more tricky maybe. Obviously they both look the same. Tangent S, tangent T, 1 tangent S times tangent T. The main thing is that when we're adding, in the numerator it has the same sign, and the denominator is different. So if the top is plus, the bottom is minus. If the top is minus, the bottom is plus. And the numerator is the exact same as what's in our combination here. And then the rest is just kind of the combination. Tangent S plus tangent T, 1 minus tangent S times tangent T. So again, you want to kind of develop these little tricks if you can, so when it does come time for memorization, it's a little more easier for you to do. All right, let's look at some examples. All right, so the first one, we want to find what is the cosine of 75 degrees. Well, with our big 3, we have what? We have 30, which is pi over 6. We have 45, which is pi over 2. We have 60, which is pi over 3. We don't have a 75. So we can't go to our unit circle page and figure it out. It's not one of those nice values. But using these formulas now, we can say what? 75 is the same as what? It's the same as 30 plus 45. Again, it's those big 3. Those are the ones you're going to use all semester. So if you get a problem like this, you need to convert it to, what are the 3 we know? 30, 45, 60. And can we use any combination to get that value? So if 75 is really 30 plus 45, we can already write this as what? This is the same thing as the cosine of 30 plus 45. So now we can use what? We can use our cosine addition formula, which was what? So this is, cosine is always what? Cosine of 30, cosine of 45, and it's always the opposite sign, O for opposite. I see plus, so this is going to be minus. And then it's what? Sine of 30, sine of 45. So these 4 values we have. These guys are values from our unit circles. Cosine of 75 we didn't have. So cosine of 30 is what? This is square root of 3 over 2. Cosine of 45 is what? Square root of 2 over 2. Minus sine of 30 is what? It's a half. Sine of 45, square root of 2 over 2. So now we need to combine these first and second terms. So the first 2 have denominator of 2. When we multiply, we get square root of 3 times square root of 2 is what? It's square root of 6 all over 2 times 2 is 4. And then minus 1 times square root of 2 is square root of 2. 2 times 2 is 4. Fortunately, they have the same denominator. So that means our answer is going to have denominator of 4. And then in the numerator, we have what? Square root of 6 minus square root of 2. So this goes back to your radical rules that you may have learned in 126. If we have square root of 6 minus square root of 2, we can't combine these and say, oh, this is square root of 4. No, we just have to leave it, right? Square root of 6 minus square root of 2. We can't simplify this thing any further. This is just our answer as far as what is the value of cosine of 75. Okay, so let's look at another example. So our second example, we want to find the cosine of pi over 12. We don't have a pi over 12 on our unit circle. What do we have? We have pi over 6, pi over 4, pi over 3. So here is the trick I would show you. If you get a problem like this, we need denominator of 12, right? So convert your big 3, pi over 6, pi over 4, pi over 3. Change these 3 to have this denominator, 12, and then determine, is there a combination, either addition or subtraction, that'll give you what? 1 over 12. So pi over 6 is the same as what? 2 pi over 12. Pi over 4 is what over 12? It's 3 pi over 12. And then pi over 3 is what? Well, that's 4 pi over 12. So I want to know if I add or subtract any of these, 4, 3, 2, will I get to 1? Well, obviously, you have two choices here, actually. You could either use pi over 3 minus pi over 4, or you could do what? Pi over 4 minus pi over 6, because that's what? 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. So this thing here is really like cosine of pi over 4 minus pi over 6. So that's how we can convert problems like this when we don't have one of our regular denominators to get the ones that we actually want. So this is a cosine, it's a subtraction, so it's what? Cosine of pi over 4, cosine of pi over 6, because this is minus, this is going to be plus sine of pi over 4, sine of pi over 6. So cosine of pi over 4 is what? Square root of 2 over 2. Cosine of pi over 6 is what? Square root of 3 over 2. We have the plus sign here. Sine of pi over 4 is square root of 2 over 2. And sine of pi over 6 is what? It's 1/2. So now I have numbers I just need to simplify. Square root of 2 times square root of 3 is square root of 6. All over 2 times 2, which is 4. We have the plus sign here. Square root of 2 times 1 is square root of 2. 2 times 2 is 4. So similar to the last problem, we have the same denominator now of 4. So that's what's going to be the denominator of our answer. And then we just have square root of 6 plus square root of 2. And that's as far as we go. Square root of 6 plus square root of 2 is not square root of 8. We can't combine those two just because we want to add what's under the radical symbol. All right, so that's two examples using our addition or subtraction formulas. So one more example for this first video, and this is going to be a proof now. So we want to prove, if you remember at the start of video 1 for section 7.1, I gave you guys those co-function identities. So like sine of pi over 2, what was it, minus u is equal to cosine of u. So now let's actually prove that. Like, okay, I gave you the formula, but do you just have to believe it, or is there a proof to it? So let's do that. Let's prove the second one. Let's prove that cosine of pi over 2 minus u is equal to sine of u. So it's a proof. What do? Pick the most complicated side. The most complicated side is what? It's the left-hand side. And this is what? It's a cosine subtraction formula. So this thing is really what? If we use the cosine subtraction formula, it's cosine of pi over 2 times cosine of u. Because this is minus, we have a plus sign. And then sine of pi over 2 times sine of u. Our pi over 2 is our s, u is our t. So cosine, cosine plus sine, sine. So cosine of pi over 2 is what? This is equal to 0. So if this is equal to 0, what happens to this whole left piece? It's equal to 0, so it's gone. Now we have the second part. Sine of pi over 2 is what? It's equal to 1. So we get plus 1 times sine of u, which is equal to what? It's just equal to sine of u, which is equal to what we had on the right side, sine of u. So really in a matter of about 1 or 2 steps, we've proved that the left side, the co-function identity, is just equal to sine of u. So that is it for video 1 for section 7.2. come on back and we will finish off section 7.2.